Hello everyone. In this video I want to look at breaking down and then adding or subtracting radicals. In this case I have the example of 3 times the square root of 45x to the third plus x times the square root of 5x. Now we add and subtract radicals. We want to make sure that they have the same radicand, what's inside the radical, the same index, and then like coefficients. Now in this example, the radicands are different, and the coefficients, the 3 and the x, we can't add anyway. But what we want to do is see if we can break it down any further. In other words, I can reduce or simplify the square root of 45x to the third. I need to think with 45, what perfect square, since we're talking about square roots, divides into 45 evenly? And that's going to be 9 and 5. Then I need to say, looking at my x to the third, with my index of 2, since that's what I assume for a square root, 2 can't divide into 3 evenly, but I can say 2 goes into 3 once, which means I'll break this into x to the second and x to the first. Now I'm going to break this into 2 radicals, the first of which is going to have my everything that I can take the square root of, my 9 and x squared. The second radical has everything else, my 5 and the x. Now I'll take the square root of 9x squared, and that becomes 3x, still times the square root of 5x. Now I want to take anything that's in front of my radical, in this case a 3, bring it down and multiply, so I get 9x square root of 5x. Looking at my second radical, I can't break 5 down any further. There's no perfect square that divides into it. And my exponent for my x is 1. And since my index is 2, and specifically my index is larger than the exponent inside, that means I can't break the x down any further at all. So this is just going to come down and be x square root of 5x. Now I have 2 like terms. They have the same radicand, the 5x, like coefficients, the 9x and the x, and they're both square roots. So finally I can add this, and I'll end up with 10x square root of 5x. This is the basic way that I approach adding and subtracting radicals. I want to test to make sure they have the same radicands, coefficients, and indices. But if they don't, I want to break them down. For example, this one's a little more complex. Cube root of 54xy to the third minus cube root of 128xy to the third. So I want to say cube root now. What cube root divides into 54, since I obviously cannot add these as they are? And that's going to be 27 and 2. My x is the power 1, which means I cannot break it down, so I'm just going to bring it down for now. Or I cannot break it down, excuse me. So I'm going to bring it down for now. 3 does go into y to the third evenly, so I don't need to break down y. I'm just going to leave it as is. My 2 radicals then are going to be 27, since I can take the cube root of that, and then y to the third for the same reason. And then everything else is my 2 and x. Cube root of 27y to the third becomes 3y times the cube root of 2x. Doing the same thing for my second radical. 128 breaks down to 64 and 2, since I'm looking for cube roots. Like before, my x power 1 can't break down, so I'll just bring it here for now. 3 goes into y to the third evenly, so I don't need to break y to the third apart, as I did in my previous example. I'll leave it as y to the third. Now, when I split into my 2 radicals, my first one is all the terms that I can take the cube root of, my 64 and y to the third. My second radical is everything else, the 2 and the x. Cube root of 64 y to the third becomes 4y. And then I still have my cube root of 2x. Now I have like terms, cube roots, 2x for the radical, or the radicand, and then 3y and 4y I can subtract, so when I do, 3 minus 4 gives me a negative 1, or just negative y, cube root of 2x. So when I add and subtract radicals, if the radicands aren't the same, then I want to break them down as much as I can, and then see if I can add or subtract them, and then if I can, obviously I go ahead and do so.